I think ours is like.
All right, so this problem is called having a girl, and it says here, let's look at the problem for a minute. It says we have 277 U.S. adults from a survey of 1,026 adults, and then it says those 277 adults would prefer to have a girl if they could have only one child. Then it says find a 95% confidence interval for the proportion of all U.S. adults that would prefer a girl if they could have only one child. All right, so what kind of problem is this going to be?
This is going to be a confidence interval.
Right, and it says right here that the confidence interval we need to compute is one that's a 95% confidence interval. All right, and the parameter that we're looking at is the proportion of all U.S. adults that would prefer a girl if they could have only one child. So we don't actually have that proportion, right? And in fact, in this case, it would be really hard to compute it because in order to compute that population proportion, we'd have to actually ask all U.S. adults how they feel about this, right?
Right.
So what we're going to do instead is we're going to compute a sample proportion based on a smaller group of individuals and then make an estimate of the population proportion from that. All right, so this time, if this is a confidence interval problem, then we need a couple things. The confidence interval problems go like this. We need to compute p hat plus e, and then a p hat minus e,
Right.
where the p hat is our sample proportion, and this capital E is called the margin of error. So what we're going to get here is we'll get an interval that looks something like this. Our p hat will be somewhere, and then our p hat plus e will be over here to the right, and p hat minus e will be back here to the left of p hat. Okay, so a couple things to compute. First, let's get this sample proportion. How do you compute the sample proportion here?
Well, we use the formula.
Okay, so p hat is going to be equal to what?
It would be equal to E equals.
Oh no, this is not E. We're not to E yet. This is just the sample proportion. So to compute the sample proportion, I have to do what?
You would get find the percentage of 1,026 and 277 adults.
Yeah, that's right. But it kind of goes the other way. You said it backwards.
Oh, okay.
We want to find the percentage that 277 represents of the total sample size, 1,026.
Yes,
so that the 1,026 goes on the top or the bottom of this proportion?
On the top. No, on the bottom.
On the bottom.
And then because you're dividing into.
Yeah, that's right. So 1,026 on the bottom. That's my what? What is this called, this number on the bottom?
The sample.
It's not the sample, the sample size.
The sample size.
Yeah, that's right. Sample size. So this is n, right?
Right.
So let's write n over here. So sample size is 1,026, right?
Right.
Now, the thing that goes on top here, the type of proportion I'm trying to compute is the proportion of adults that prefer a girl, right?
Right.
So in my sample, how many of those do I have?
That would be 270.
Yeah, so that goes on the top.
Okay.
Okay, so let's get this as an actual number here. So I need some math magic. 277 divided by 1,026.
Okay, that would equal 0.2699.
Okay, good. So about 27%, right?
Right.
Kind of an astounding number, right? Okay. Anyway, all right. So that's our p hat. Now, hopefully, this is going to be an estimate, a good estimate for the actual population proportion, right?
Right.
So the whole game here is we're hoping that this p hat is close to theta, the population proportion. But in this case, I don't actually have theta. All right. So at any rate, the number in the middle here is going to be 0.26. Or about 27%. And now we need to figure out what each of these endpoints is. And the way we're going to do that is compute this E.
Okay.
So I need a formula for E now. This is called the margin of error.
Right. So that would, E would equal P hat. Oh no, that would be the Z star.
Z star, that's right.
And square root.
All right.
Of P hat.
P hat, which we have.
And 1 minus P hat.
That's right. And then on the bottom?
Would be N.
The sample size, right?
Right.
Okay. So that's the formula for E when you're doing a confidence interval.
Right.
Now let's see if we have the different parts here. Let's start at the end. We have this N. What's the N?
The n is the 1026.
That's right. And do we have this p hat?
Yeah, that would be the 26%.
Yeah, that's this guy
Oh,
up here, about the
27.
27%.
Right.
What about this z star? Where does z star come from?
Oh, that would be the confidence level.
Right, it comes
So
from the confidence level, which in this case is
95%.
that's 95%. Now, there's a table in the book that gives us this z star. This is the z star is called the critical value. But at any rate, it comes the thing that you need to remember is it comes directly from the confidence level. Now, if our confidence level is 95%, check the table and find out what z star value we should be using.
Right. Okay, that would be 1.960.
All right, so let's put it all in. It looks like we got it all. So this is 1.960, right?
Right.
And the square root here. And what's our p hat again? That's
Would be
the
27%.
0.2699. All right, we'll carry along the digits for accuracy's sake here for a minute. Okay. That goes in here. What's the sample size again?
That would be 1026.
Okay, so we're going to put that all in there. All right, good. So let's simplify this a little bit. So 1.960. So in here I got 2699. Subtract that from 1 and tell me what you get.
Point two.
0.2699. And say minus 1. And then the sign will be wrong, but the number will be right. Oh, yeah. What is it?
0.7301.
Okay, good. So that goes in there. And then divide by, let's put 1026 down here. All right, so let's do this all together. 0.2699 times 0.7301 times 0.7, oops, wait a minute.
Oh, because I left it as a negative.
Yeah.
Okay.
0.2699, start with that.
0.2699.
Times 0.7301.
7.
What do you get for that? Say equal.
Would be 0.19705.
Okay, and let's divide that by 1026.
Right. 1,000.
Equal.
That would be
So some very small number. We got to take a square root of it, so go ahead and take the square root of it.
okay.
So for this, yeah, that's right.
Okay.
That sounds right. So read it off to me.
Okay, so it's 0.0138.
Yeah? 1, 3,
8.
8, 5. Okay, so something like that. So
Okay.
take that number and multiply it by 1.96.
6. Okay, and then you got 0.02716.
0.02716. Okay, good. So now that's the E. So the E value is going to be 0.02716, right?
Right.
So in terms of a percent, what is that? About what?
That would be around, about like 3%.
About 3%. So
Okay.
let's actually figure out what P hat plus E and P hat minus E are going to
Okay.
be. So P hat plus E is going to be 0.2699 plus this 0.02716. So take that number right there and add 0.2699 to it.
Okay, 2,699.
What do you get? Equal. Oh,
0.
that's all right. That's
Yeah.
fine.
2716.
Equals.
Okay, that would be 0.29.
That makes sense. Yeah,
70.
0.2970. Okay, good.
Right,
Let's do the P hat minus E.
right.
So that's all, again going to be 2699 minus 0.02716.
And you got 0.2427.
Okay, good. So our interval goes from about 0.24. Let's round off to 3 digits after the decimal here. So it starts at 243 and it goes up to 0.297, right?
Right.
And that's our confidence interval. This is the lower endpoint of it, and this is the
Oh.
upper endpoint of it. And what we're saying is we're about 95% sure that the population proportion is somewhere in that interval.
Right.
So between 24 and 29, roughly between 24 and 30% of U.S. adults would prefer to have a girl if they could only have one girl or one child.
Okay.